In this video, we are going to create two types of ice volume shader. This shader has no volume in them, but they have a parallax effect that is going to fake the volume. This method is not just for ice. You can apply this method to many other materials and create some cool effect. So before jumping into the code, let's see what we need to do. Materials like ice are not completely transparent, but you can see the layers below the surface of them. So imagine this is the top layer of the ice, and this is the eye position. So as I told you, in material like ice, you can see the layer below surface. So these are the layers below. And now if we look at the ice at a different angle, the thing is the layers below will move compared to the previous position. And as the depth of the layer is bigger, it is going to move away further. So we need to create a shader that mixes multiple layers, and each time we change the angle of the view, the layer below to the surface moves. And as the layer has more depth, it's going to move further. In Godot shader, we have this view vector in fragment function. But the question is how we should move these layers. Because our view vector is in 3D space, but the only way to move this layer is by modifying their texture coordinate. So how we can make a relation between these two? Well, this is a tangent space. And as you know, each point on our mesh has a different tangent space. And coordinate system in this space is defined by normal, which is perpendicular to that point on mesh, and tangent and binormal, which are parallel to mesh. So fortunately, tangent and binormal have the same direction as the x component of our UV and y component of our UV. This means if we can bring our view vector into tangent space, then the x and z component of our view vector are in the direction of tangent and binormal. And this is the same direction in UV or texture coordinate system. And we should move our texture along this vector. I hope you understand that, but if not, write a comment and tell me where should I explain more. I create this small scene in Godot and I create a plain mesh with an empty shader. For this, I download the ice texture from Ambient CG and I will put the download link in the description. First, I declare my sampler to the uniform for albedo, normal map, and roughness texture. And then I define a vector 2 with the name of base UV. And because my plane is big, I scale it 5 times. Well, the correct way is to scale this in a vertex shader, but I will do it here anyway. Well, now I set my albedo, normal map, and roughness with my base UV. I hope to this point everything was clear. Now we should calculate the view vector in a tangent space. In fragment shader, there is an input which is called view. And this will give us the view vector in view space. View space is a space which camera is in middle and its position and rotation is 0 and everything else is around camera. So we should create a transformation matrix which transforms from view space to tangent space. In fragment function, we have also tangent, normal, and binormal vectors in view space. So what we do now is to create a 3x3 matrix from these vectors, which the rows are the tangent, normal, and binormal. Because these vectors are in view space, they are going to transform from tangent space to view space. Yeah, this is how transformation matrix works. If you are confused and don't know how they work, search about them. They are not too complicated. The thing is that we want the opposite transformation from view space to tangent space. And the way to do that is by making the inverse of this matrix. So let's do it. Here I create my matrix and then I create a vector which I call it T-view, which is our view vector in tangent space. And then I multiply my inverse matrix to view vector. So that will work and there will be no problem. But there is a better way to do that. Basically, our transform matrix has 3 orthogonal vectors in it. I mean tangent, normal, binormal are perpendicular to each other. Is that right? So these kind of matrices are called orthogonal matrices. And they have a special property which the transpose of this matrix is equal to inverse of that. You can search on internet about this. There is a mathematical proof to that. So here, instead of inverse, I write transpose matrix. And this is much more efficient because inverse matrix take much more processing power. Now, GLSL language has a special property which if you reverse the order of multiplication, it will get the same result. And we are done. This was the hard part. And now the rest of this is easy. And from this point, you can use this view vector in many ways to make many cool effects. But here, I just showed to you two of these methods. So now I grab the x, z component of my view vector and put it inside my move uv vector. So this move uv vector is the direction which different layers should move to give us a parallax effect. Now for testing, let's add our move uv to base uv in albedo texture and see what will happen. So it is moving, but it has not the direction which I expect. Remember that I told you tangent and binormal are in the direction of x component of uv and y component of uv. Well, it seems binormal is not, and we should flip that. So multiply binormal by -1 and everything will working. So everything is working now. Just sometimes we have some artifact like this. And that is because move UV is too big. Later we are going to multiply that with a factor to make that smaller. So now we need a texture for parallax effect. You cannot use the albedo picture for parallax effect because albedo texture has a lot of detail in it. And if you use this, you will get a blurry effect, which is not good. The texture which I choose is this, which in most part is black. This is a scratch texture which I download from Ambient CG, and I will put the download link in the description. So in my shader code, I define a sampler uniform for my parallax texture. And I also need two more uniforms. One of them is the number of the layers, which refer to number of layers under the surface. And I define depth, which is the depth of the lowest layer. Now I define a float variable in fragment function and I call it layers. And I set it to 0 right now. So here I create a for loop for each layer. And done. I define a float variable which is called ratio, and this ratio for the first layer is 0 and for the last layer is 1, and for layer between is between 0 and 1. Now we should sample from parallax texture. And the tricky part is that how much we should move from base UV. Well, we have the direction which we should move, which is defined in move UV vector. So I add move UV to my base UV, and as we know, for the layer which is lower, we should move it further away. So I multiply these to mix 0 depth ratio. So this will give us the value 0 when the ratio is 0, and it will give us the value depth when the ratio is 1. And for the value between 0 and 1, it will give us the value between 0 and depth. Because we add to layer multiple times, it is a big number. To make it correct, we calculate the average of the layer by dividing that to num layers. Well done. It is finished. Now just add the layer to albedo. And everything is black. That is because the number of layer is 0 currently, and here we divide to 0. So that will cause the problem. Now if I change the number of layer and depth, let's see what will happen. As you can see, this is working and you can do a lot of cool stuff with this. For example, I add my variable layers to emission and I got this effect. So this was the first method to make parallax effect. This method is need enough processing power because you sample multiple times from parallax texture. Next method needs less processing power, and we don't need a parallax texture for that. Instead, I'm going to use my albedo texture for below layers. So I delete these. I only add depth uniform. So now I move my albedo texture one time and I mix it with my original albedo. First, I'm going to multiply move UV to depth. And then I sample from my albedo with this move UV. And I put that inside albedo under variable. And then I mix between albedo and albedo under, and I put the mix ratio to 0.6. But you can change it if you want. Well, now if I change my depth and move around, as you can see, texture under my surface is going to move. But still this effect is not good enough. So the way you can make this better is by multiplying a noise value to depth at each point. So each point will have a different depth. So I add another sampler to the uniform for my noise texture and set a noise texture to it. And then I'm going to read from this texture and multiply this value to my depth. So as you can see now, each point under my surface has a different depth. And this will make it more realistic. In this method, because we sample only one time for the layers below the surface, it's more efficient and it needs much less processing power. So the concept of the parallax effect is this, but you can make it even better. Just be creative. And this is the end of this video. If you have any question or suggestion, let me know. Have a good time. Until the next video, bye.